I'll make the observation here that for part A, this really should have been equals 6, not equals 5. That's probably a typo. Here's a picture of the graph of xy plus x squared y squared equals 6. That's these red curves right here. And here's the point 2 comma 1, which does look like it's on the graph. And here's the equation of the tangent line using point slope. So we know the point. The problem is, how do I find the value of the slope of that tangent line? And that's where we have to implicitly differentiate this relation with respect to x. That is, find dy dx, which I've written as y prime, instead of writing dy dx. For each of these terms in the original function, we have to use the product rule because we have the product of two functions. So I like to say for the product rule, it's the first times the derivative of the second. And whenever we're taking the derivative of y, we have to say y prime. We're assuming y is a function of x. That is, if we could actually isolate y, we could get y prime explicitly. We're not going to try to get y by itself. We're just going to differentiate with respect to x implicitly. Okay, so first times the derivative of the second plus the second y times the derivative of the first function would just be a 1, plus first function is x squared times the derivative of the second, 2y, reduce the exponent by 1, times the derivative of the inside. That's where we're employing the chain rule right here. Plus the second function, y squared times the derivative of the first 2x. Now at this point right here, you could put 2 in for x and 1 in for y and solve for y prime, and that would be the slope of the tangent line. You would get -1/2. If you actually want a formula for the derivative of y with respect to x, get the terms with y prime on the left side of the equal sign, all the other terms on the right side of the equal sign, which is what this line shows. Factor out the y prime from the two terms on the left, and then finally divide by the coefficient of y prime, which is this expression right here. So there's your formula for the slope of any tangent line to the curve at a given point on the curve. We see that 2, 1 is indeed on the curve, so we put 2 in for x, 1 in for y, we get -1/2. There's the equation of the tangent line, which you could put into slope-intercept form if you wanted to. Now, part B is similar. I'm going to leave that to you, but we have to use the product rule for each of these terms. You might want to go to Desmos and type in this function to see what it looks like. Make sure that 2, 0 really is on the curve. So there you go. Hope that helped. If you need any clarification, post a comment.